In this video, I will demonstrate end-to-end tank analysis using uniTank version 1.3. So here, I have a set of unregistered datasets of an internally scanned tank. Prior to this, I used the import points functionality to convert the raw scans into uniTank's internal data format. For more information about this, please see our importing data video to learn how to bring data into the uniTank environment. First off, we are going to color the layers to random colors so that we can differentiate them from each other. We can have a look at our data by moving around using the left mouse button or rotating using the right mouse button. You can also quickly switch between top view and side view by hitting T for top or S for side on the keyboard. We can limit the data we see on the screen by constraining the elevations that are shown. Using the constrain Z function, we can view only a thin horizontal slice of data so that we isolate certain sections of the tank. Using the page up and page down keys, we can quickly move these limits up and down. Next, we are going to estimate the diameter of the tank. If you already know the diameter of the tank, you can skip this step. I'm going to use the circle tool to trace the shell in one of the scan layers. Holding down the Shift key, I can create a circle drawing by clicking two sides of the circle. I'm going to use the Find Circle tool to fit the circle I have drawn to the data. This will give me a very accurate measurement of the tank's diameter. You can use the Circle Find tool to not only estimate shell diameters, but also column diameters and areas. Using the layer control here, you can also select whether you use data from all layers or just a single layer. All these controls within this area apply only to the layer that is selected. Since our data is not yet registered, we only want to use the layer that we used to trace our circle. Now that we know the diameter of the tank, we can perform course registration. This process will roughly align all the scans. Now, we want to refine the registration. First, we want to automatically add fiducials. Fiducials are areas where we look for common surfaces or columns between the scans so that we can tie them together. You can manually add fiducials as well using the Define Fiducials function. The surface fiducials on the shell control horizontal translation. The surface fiducials on the floor control vertical translation. Finally, the column fiducials at each column control Z-axis rotation. We will discuss the topic of fine registration in more detail in subsequent videos. Once we are satisfied with our fiducials, we can run snap fiducials. What this does is it finds the best fit model by positioning each scan layer so that the surfaces and columns are as close as possible. If you get a warning that snap fiducials did not converge on the first try, just run snap fiducials again. However, if you find that it consistently does not converge, run the check fiducials tool. Look to see if there are fiducials with high error. If so, remove these and try running snap fiducials again. Now that we have a registered model, we want to ensure that any manipulations we do after this, we do to the whole model. So we are going to check off the All Data and Definitions checkbox here. At this point, we want to orient our model to a specific reference point. Typically, we use the floor to shell weld at the north manway. To do this, we simply need to add a point using the Point tool near the floor at the north manway. We can then use the Find Plane tool to fit this point to the floor. First, we want to move our model vertically so that the floor at this location is at 0. We do this using the Translate Point function. Next, we want to move the model horizontally so that the manway is positioned to the north using the Rotate Point function. So we just have one more step to do before we do the analysis. We need to classify each point either as shell, floor, roof, column, beam, or other. We need to define the top and the bottom of the shell, and uniTank will figure out the rest. So again, we want to use the Find Circle tool to trace the shell. We will set the bottom of the shell at 0. Now, we can estimate the top of the shell visually. Here, we can see that it is about 32 feet high. We will set the top of the shell at 32 feet. Typically, the tops of the shell will be multiples of 8 feet. We will run the AutoClassify tool using the default settings. Since we don't have a floating roof in this tank, we will uncheck that option. uniTank has now classified all the points into their appropriate classes. We just want to double check a few classes to make sure there's nothing missing. You can visually inspect each of the individual classes by isolating the points that pertain to each class individually. In uniTank version 1.3, you no longer have to define the columns. uniTank will find them automatically for you. You'll also notice that the columns are cut very cleanly from the floor and from the beams above. If we see some shell data in others, we can simply draw a polygon around it and reclass it to shell. Similarly, if we see floor data in others, we can simply reclass it to floor. When we are satisfied with the classifications, we can move on to analysis. All the tank analysis tools are located in this tab. Before you start any analysis, you must first define the tank properties. In most cases, you can leave the default parameters as they are when running each tool. All the plots are written to the output file location. In the output folder, you will find many more outputs such as cross-sections and data files. Once all the analysis tools have been run, a report can be generated automatically. You can customize the format of the report by modifying the template located in uniTank's install directory. Review the report and remove any sections that do not apply to your tank. The last step is to update all the smart fields by selecting the entire report and pressing F9 on the keyboard. You may want to do that twice to ensure all the tables are updated properly. One additional feature of uniTank is that you can also use it to present results to clients. Using the Load Output tool, you can import all the display models in 3D and view them in great detail. This tutorial gave you a high-level overview of uniTank. Please see our other videos for tutorials that cover specific topics in greater depth.